Lord, we pray that all benefit will all go away with knowledge, increased wisdom, in the mighty name of Jesus. And we pray that this will be an encouragement to everyone who has even come to listen, that they will benefit. You will give them, as we said, this should be a gateway. It will be an inspiration for people. And we trust you, God, that the Bible says that you that have started a good work, you are faithful to complete it, that this will just be the seed that will grow into a mighty tree. And because we have faith and we agree and we believe that it is done for us in Jesus' name, amen. So once again, welcome everyone to today's session. As you can see on the screen, it's the wisdom class inaugural. We can say very, very first, even for CHM presentation. And we're hoping that there will be a part 2 towards the end. It's good to just set the tone to say the wisdom class, they've been barely, I would say 6 to 7 weeks into their lesson, and they've worked so hard. This is just so good modeling. They've really, really shown that they are the wisdom class, they are the seniors here. And they've put together some of the concepts they've been learning under Dr. Sam. They've gone away, researched as well, and they've come together today, very organized, to dish it out to us. So sit back, sit tight, listen. I would invite Madam Joy shortly, but there will be time for questions. I can just say it now as well. So if you have questions as they're presenting, make a note of it. There'll be time, 2 blocks of time for session, for questions, sorry. So it will be the wisdom class presentations, then we'll have a short break. There'll be another batch of presentations, and Dr. Sam, Pastor Gibson will come in, and they will do a reflection as well on the experience so far, especially if you're in knowledge class and it's something that you're looking forward to. So this is a good opportunity to have a sneak peek into what machine learning is all about. This is a good opportunity. So again, sit back, and it's my pleasure really to hand over to Madam Joy Opute and the fellow leaders to take it away. Thank you. God bless.
Thank you so much for that, Dr. Victoria. Good afternoon, everybody. And once again, welcome for being here. The Wisdom class, we are so excited to show you what we have been learning so far. So I'll now go ahead and share my screen. Can we just confirm if we can see my screen?
Yes, we can.
Fabulous. Thank you so much. So, good afternoon, everybody. My name is Joy Opute, and I'm presently a student of the Wisdom class and formerly a student of the Knowledge class. So for some of you who are in Knowledge class at the moment, I was once there. And I will be giving a general overview of machine learning. However, my colleagues will be giving you more intricate details, and I'll be introducing my colleagues as we go on. But just as Dr. Victoria has said, we'll be taking questions from the audience in the middle of our presentation and at the end. So as we go along, just note down questions that come to mind and write down maybe the slide or the name of the person who's presenting at the time, so it can help us to direct to the correct person to answer your question. So once again, welcome. Now, we are talking about machine learning today, but what is machine learning? It's almost impossible to talk about machine learning without talking about data. Ideally, we're just going to look at the real world that you and I live in. Okay, so we either have questions that we're trying to answer, okay, or we have problems that we're trying to solve. Now, for example, if you had a question or you have a problem you're trying to solve, you will always need data regardless to do that. Now, when we collect data, we want to organize it, we want to clean it before we can make use of the data. Now, ideally, when you have your data, you have to explore the data, okay? But if what your intention is just to answer questions, then you can say, okay, you are just more than happy to use your data analysis to answer questions. But if what we want to do is to solve real life problems, then that's where machine learning comes into play. And we'll have to go through the process of machine learning cycle to be able to solve our problem. So I will now take you through the beginning of a machine learning. With machine learning, like I said earlier, you need to identify the problem that you're trying to solve and then collect the data. Okay, so just to bear in mind, the cycle in machine learning overlaps. Okay, so because they overlap, As we go on, I will show us on the slides which parts links to which one. So right now, we have 4 specific parts of machine learning. Okay, so we have the supervised learning, the reinforcement learning, we have the semi-supervised learning, and we have the unsupervised learning. Now, regardless of what part of the machine learning you're trying to use, we are hoping to apply data. The problem you're trying to solve or the sector that you're focusing on will determine the type of data that you create or collect. So that then brings us to the level of importance that machine learning has in the world that we have today. Now, the world is so advanced to the extent that you can use machine learning in every sector. So up here now, we have in the health sector, for example, machine learning can help in the diagnosis of disease or even personalized treatments. So some of the problems you may want to solve, we could say, can we predict disease onset, for example, diabetes or heart disease, or based on medical history and lab results? Or the problem we want to solve could be, can we optimize patient treatment plans using historical outcome data? So in a case like this, then your data will be coming from patient records. Now, in finance, machine learning can help with things like fraud detection or help with trading. So here, if you have a problem you want to solve, an example of the problems we might want to solve will be, can we predict the stock price movements using like historical data? Or how can we detect fraudulent transactions in real time? So in the case of finance, then your data will be coming from historical stock data. Now, machine learning is so good that even in retail, it comes in handy. So we can use it for customer recommendations and things like inventory management. Now, some of the problems you could encounter and want to use machine learning to solve will be, can we forecast inventory demand to reduce overstock and understock issues? Or can we personalize shopping experience? Okay, so using the customer behavior data. Now, in a case like this, your data will be coming from either the stock data or the customer data. Now, we can also use machine learning in transportation as well, which is just fabulous because it will help in things like autonomous vehicle or like traffic prediction. So some problems we might say we want to solve here could be, can we predict traffic congestion at different times of the day? Or how can we optimize delivery routes for logistic companies, for example? Or even nowadays where they're beginning to talk about self-driving cars. So the problem could be, can self-driving cars identify and respond to road obstacles using computer vision? And it doesn't even stop there. We also have entertainment as well, because machine learning is used in every single sector you can think of. So in entertainment, machine learning can be used in content recommendations or even in gaming. So some problems could be, can we recommend content to users based on their viewing history? So for someone like me, I love watching Netflix. So it could come in handy here, or even for those who enjoy Spotify. And then another way we can use this could be, how can we identify and block hate speech on spam using NLP? So this is just the beginning, talking about how machine learning can help us. Now, we've spoken about identifying the problems, we've spoken about data collection. I would now like to welcome my colleague, Mrs. Helen, to tell us more about the EDA, the DTL, and data cleaning in machine learning cycle. You're welcome, Ms. Helen.
All right, good afternoon, everyone. My name is Ali Nobona, and I will be talking about EDA, ETL, and data cleaning. Okay, so I will first of all want to explain what these terms mean. EDA means exploratory data analysis. ETL means to extract, transform, and load your data. In summary, I want to explain that the goal of EDA and ETL is to give us a better understanding of our data sets, help us to prepare our data as well as visualizing it before we dive into modeling. Okay, I would like to explain with a real life scenario of what EDA is all about. Look at a person who wants to go to the market to get some items. Going to the market to get an item, before you set out for your journey, you need to have a list of items you need that you get in the market. Because if you go to the market without a list, you find that at the end of the day, you might go and buy things that are not necessary for you, or you end up wasting money. when you come back home and you're like, this is unnecessary. So the essence of EDA is to help you to know what exactly you want and know what exactly you will get when you get to where you're going to. Another example you could look at this is you want to set out on a journey. You're going to a place where you don't know, and you need to get information about the place, possibly reading a map to know the routes and how you can be able to navigate through the road. In case of blocks or roadblocks that will hinder your journey, you know, if I'm going to follow road A, that means there'll be a roadblock there. That means I need to take road B to get to my destination and get there on time. So I have brought up an analogy to be able to explain how the steps in exploratory data analysis. Now, looking at my screen, you will see my data. It's Christmas, and I want to prepare or make a cloth for myself and my siblings. Before you can do that, you need to source out the materials you will need to make your cloth. So the very first step in exploratory data analysis is for you to gather and collect your data. Now I have my wrapper and I have the design of the cloth that I want to make at the end of the day. Now, it doesn't end there. For me to be able to progress in this journey, I need to take this, my wrapper and the design I have, to a tailor shop that will help me to actualize this particular goal. Now, this is me at my tailor shop trying to give the data to my tailor, the data which is my wrapper and the design I want. Now, the tailor shop will look like a target system where you want to use to actualize what you want to do at the end of the day. Giving the tailor your material and telling you that the tailor will have to take your measurements, check your board size, check your cap size, your hips, and all the measurements that are necessary for her or him to be able to get this work done. He will do it. So after this stage, here now you can think about in data analysis or data science, wherein you will need a system, maybe a database or a data warehouse. Anyone for data science, we use Python. That will be where you'll be able to load your data. That's where we have loading in ETL to load your data into a particular system to enable you to read it. There are some libraries in Python that have been inbuilt that will help you to be able to visualize your data. So the tailor is done with the process of picking up the data she will need, the board size, and so on and so forth. Here is the tailor downside, trying to make a sketch of what he or she will need at the end of the day of the design. Now you can see where the tailor is sketching it and then the outcome of whatever he has done. So this thing plays, this particular visual sketching of the images you will use shows data visualization. In everything you do in exploratory data analysis, if you don't visualize your data, you might end up getting stuck on the road. So here I'm going to talk about the steps, just like I used that analogy to explain the various steps. The first one is collecting your data first. So you need to know what you want, first of all, before you know where you can get your data from. That's the first step. After you've collected your data, the next step to do is to load your data into a system, depending on what particular program software you're using, either a Python or any database, maybe a MySQL or PostgreSQL that you're using. So you load in your data to that system. After you're done with the loading process, the next thing is for you to perform some statistical summary of your data. This means that you would either check the mean, you either check the median, which is the middle number, or the highest occurring number in a particular data set, depending on what you're working on. You try to summarize your data, do some certain cleaning. Now, if you look at a tailor, once the tailor gets the material, the tailor will be able to cut out the materials that she has into different shapes according to the size of the person he or she wants to produce the material for. So this is exactly what happened. The tailor will be able to identify whether there are spots in the material, whether there are any problem that could be able to affect that production at the end of the day. So this is what happens when you're trying to work on your data, to clean it, to check for outliers, check for missing values in your data sets, so that you get to know more about the data you are handling with. So the next step you would take there, okay, like I said earlier, checking your missing values and outliers. Outliers are low or high values that might skew your data in future when you're modeling that particular data. Then, as you see as you're working on that particular data, you're already transforming it, trying to clean the data, running some aggregate functions like sum, count, checking the maximum number in your data set or the minimum number in your data set. And then lastly, when you're done with this, you have to visualize your data using either a histogram, a line chart, or so. There are some codes I ran during the process of this presentation to be able to explain what each of these code does in EDA. Now, the first thing I had to do from my right-hand side, you will see that I imported these libraries that are inbuilt inside Python, like Pandas, Matplotlib, Seaborn, and NumPy. These libraries will help you to visualize your data. After I did that, the next step is to load in my data, where you have df equal to pd.read. I have a CSV file I worked with, which is the songs data. That's what I used for this particular coding. And then the next step I did was to check the first lines of row, where you have df.head. It will help you to check the first lines of row in your data set. Inside the parentheses, you will notice I put in 3 there. So that's why I have 3 records on there. If you want, you want to check 10 records, that means you put the number of records that you want. The next step I did was to check my data type. The data type of my, so you can see from song ID, I have integer and so on and so forth. Then by the right side, data code was to give me a summary of my data set. You can see it's showing me that the number of data I have there is 10,000. It's telling me about the mean, the standard deviation, my average, and the percentage, 25% of my data, 75% of my data, and so on and so forth. So these are steps you take in exploratory data analysis. It doesn't end there. After the whole steps you've taken, you need to visualize the data. As the teller is sewing, he or she has her sketch beside her to guide her to make the production exactly according to the person's size. So you need to visualize your data in order to be able to explain better, even with somebody that does not know much about whatever thing you are doing. So that's where the use of histograms, pie charts, bar charts, and so on comes in play. Generally, I would want to say that data cleaning ensures, number one, data accuracy. You know well about the data you're working with. It helps you to be able to predict the final outcome in your work. And then finally, it helps you in being consistent in what you are doing. Thank you so much, and God bless you.
Wow, thank you so much, Mrs. Helen. That was a wonderful analysis on EDA data cleaning. Everyone, that's Mrs. Helen. If you have any question for her about EDA data cleaning, just write it down and have a name next to it, and we'll listen to your questions later. Thank you so much, and I'll be heading to my tailor very soon. Right, let's have Mr. Gbemisola for feature engineering. Welcome, Mr. Gbemisola.
All right, thank you very much, Madam Joy. Good afternoon once again. My name is Gbemisola. I'll be talking about feature engineering and data transformation. The first thing and the first question that we need to ask ourselves is, what is feature engineering when it comes to machine learning? Yes, what is feature engineering? Feature engineering is the process of transforming raw data into features that are suitable for machine learning models. In other words, it is the process of selecting, extracting, and transforming the most relevant features from the available data to build more accurate and efficient machine learning models. Now, guys, I would like us to pay more attention to the keywords there. We're having feature, transforming, and raw data. The next thing we're having here on my slide is what is feature in machine learning. Don't forget I said you should pay attention to the keywords we're having feature. What is feature? Feature is, in the context of machine learning, a feature, also known as a variable or attribute, is an individual measurable property or characteristics of data point that is used as input. So which means anything that we use as a data as an input, we call it feature. And I will now explain this particular feature using a diagram where we have raw data, the features, and the modeling. As you can see in between, as you can see in between raw data and features, we are having feature engineering, which means the process of transforming the raw data into a suitable feature. That's where we are going to perform feature engineering. So I will now move to techniques to perform techniques in perform feature engineering. There are many of them. We have 9, we have imputation, we have handling outliers, we have binding, we have log transform, we have one-hot encoding, we have grouping operation, we have feature split, we have scaling, we have extracting data. Furthermore, I will be talking about the scaling. I think my other colleagues will be talking about the other techniques. So when you are talking about presentation of the data, don't forget I talk about raw data. Mainly looking at this particular table, this is our raw data. As you can see, when we are performing data analysis, this particular data is good to go unless if you are going to change the empty set there. But as for machine learning, this data is, we can't use this particular data to train in machine learning, to train a model in machine learning. You have to perform some changes, or you have to do a little feature engineering. The first thing we are going to do there is what? Changing the entire column required encoding. As you can see, under the level column, we are having some values there. So in machine learning do understand 500 level, 300 level. What machine learning understood is a number, numeric value, which starts from 0 to 9. So when you're having data going to 10, 100, thousands, billions, machine learning cannot deal with such values. So we need to encode our values, our features, to so that we have suitable with our model. So the second thing we are going to do is to remove the missing value, which is missing information. And there are many ways we can do that. That's imputation, where we can remove the entire column if it's not going to affect our model. It's not going to affect us in training our model. And also we can also remove the entire row. Either we remove the column that is having the non-value, or we remove the entire row. So that is where we can perform, correct the missing value. Or there are another way we can do all that also. So we learn that in our next slide. The next thing on my slide is data transformation. We all know that it's the process of transforming the feature into a more suitable representation for the machine learning model. This is done to ensure that the model can effectively learn from the data. Everything that I said about the raw data, this is where we want to use it now. So as you can see, under I made mention of imputation. So imputation is, like I said before, is dropping. We can drop down or replacing the non-value with some values. So what are the values that we can replace? We can replace the non-value with. We can replace it with 0. As you can see in the code below, we're having data. You have data.column, which is the particular column you're having. If is known, which is data.isNown, we can replace it with this particular code will help us calculate, checking the threshold. So we are going to get that very soon when we move to the another place. So another thing we can do is what? By numerical imputation, where we can replace the non-value with 0, or by median. So that will prompt us to the next slide, where we are having the examples of what we have done. Don't forget that I said that we can machine learning understood 0 to 9. So for us to have a clear understanding about how we train, how we use our feature engineering. So example of scaling, that's the code and that's the output. So we are having the our values, which is 2, 14, minus 23, 85, 28, 235. So as you can see, after we have performed our scaling using normalization method, so we are able to achieve another value where we can use to train our model. So after that, we go to standardization. That's the code. Let's have the output again. So that is the output. As you can see, we are having negative value, negativity value in standardization. So when we now come back to log transform, that's where we train our value. In order to have a valid input, in order to have a valid fixture to train our model. So that's why we're having log value. Another method is log transform, where we have transform the value. As you can see, under log x plus 1, we are having none. Actually, we are having minus because log cannot deal with negativity number. So that's where we have another aspect of logarithm, where we can able to treat any negativity value. So that's where we have 0, 0, 0. And with this, we are ready to train a particular model. Thanks for listening. Thanks, everyone. Over to you, Madam Joy.
Thank you so much, Mr. Gbemisola. That was really fantastic. Everyone, that's Mr. Gbemisola. If you have any questions for him under feature engineering, you can note that down and he'll be able to take your question later. Right, I would like to introduce Mr. Okopi to talk to us about encoding of categorical variables. Welcome, Mr. Okopi.
Yeah, thank you, Madam Joy. Good afternoon, everyone. My name is Okopi Odumu, and I'm here to speak on encoding of categorical variables. Okay, before we talk of encoding categorical variables, we have to just briefly discuss machine learning, as my colleagues have done before. Machine learning definitely only works with numbers or numerical data. They do not support strings and non-numerical data. So for you to convert data that are not numeric data, you need to encode them. That is just what encoding basically means. Converting non-numerical data into numbers or numerical data so that the models can understand them and predict. Now, when you talk of categorical data, there are basically two types, the nominal and the ordinal types of data. So an ordinal data is the data that is categorized, like they have a natural order or ranking. For example, small, big, large, primary school degree, secondary school, certificate, university degree, PhD, in that order. And it's basically used to predict or understand trends in a data set. While a nominal data doesn't have any order, just for example, gender like male, female, colors, they don't really have an order, and they can be used to group different data sets. Now, under the nominal type of data, the most common one to use for encoding is the one-hot encoding, while the ordinal data, the most common one is the label encoding. So now, what's the one-hot encoding? It just simply means converting your data, that's the non-numerical data, into a binary format, which involves 0 and 1. For example, now in our code here, we can see we import the pandas first, and then in our data here, in our data set here, we can see the names of our lecturer. We can see Dr. Sam, Pastor Gibson, Dr. Victoria, Dr. Yemisi, and Dr. Sam again. By the end of the day, when we encode this data from the results you can see here, you can see that under Dr. Sam, you can see they are true. True appears twice because in the data set here, Dr. Sam's name appears twice. So where you see true, it means 1. Where you see false, it means 0. That's what this type of encoding entails, just basically changing it from 0 and 1. Now, when you move to the label encoding, it just simply means assigning an integer to different data sets. For example, we can see here we've exported our sklearn, which is very important when it comes to machine learning. You can't do without it. We imported the label encoder, and then from our data set here, we use fruit here. We can see tomato, we can see spinach, pepper, spinach again, and tomato. Now, when we go to the next code here, we can see that we called back the we assigned the data here, and then we use this feed transform. This feed transform here is the main deal. It transforms all this data here to numbers by assigning different integers to them. So for example, here, when you see tomato here, you can see 2. Wherever you see tomato, you can see that it was assigned in integer 2. Wherever you see spinach, it was assigned the integer 1 and pepper for 0. So basically, you need to encode your data before you can actually build, before you can, your models can be able to understand them and then make predictions with them. Thank you.
Thank you so much for that, Mr. helping us to understand with everyday objects that we use. At this stage, we'll then welcome Mr. Babatunde to talk to us about dimensionality reduction. Can we have Mr. Babatunde, please?
Good afternoon, everyone. My name is Babatunde Quadri. I'll be talking to us about dimensionality reduction in machine learning. And good afternoon, you all once again. When you talk about dimensionality reduction in machine learning, it's simply a technique used to reduce the number of features in a data set while retaining as much of the important information as possible. To reduce, please note this, to reduce the number of features in your data set. My colleague has talked to us about features. Features are measurable properties of a data set that are used to train and serve our model. So that is what features is all about. So in other words, it's a process of transforming high-dimensional data, high volume of data. You have a data set that has so many columns, so many rows, and you want to model this data. In order for you to get accurate result, a good result, you need to perform what is called dimensional reduction on it. And there is no way you talk about dimensional reduction that you won't come across something that is called cost of dimensionality. In machine learning, cost of dimensionality is, it happens when the performance of your model deteriorates as the number of features increases. When your model, the performance of your model deteriorates, when you have an high dimensionality in your data set, you might come across what is called cost of dimensionality. So in machine learning, in dimensionality reduction or dimension reduction, is still the same thing. If I say dimension reduction or dimensionality reduction, I'm still talking about the same thing. We have two main features, two main approach, which talks about feature selection or feature extraction. When you talk about feature selection, it's simply, this involves, selecting a subset of the original features. From your original features, you select some subset of it to be able to, when you train with it or you test with it, you'll be able to get, a good result. So features that are most relevant to the problem at hand. For example, you want to predict the price of a house. You have a lot of features, like the square feet of the house, like the age of the house, the location. You look at they might even give you the zip code, or they might give you the number of rooms, the number of floors, areas, and the likes. But by the time you want to determine the price of that house, zip code as a feature in your data set is not necessary. You might decide to drop it and reduce your data set to what will give you a good result. And we have, under the features selection, we have methods like filter methods, wrapper methods, and embedded methods. All these are some of those features that can really help you in selecting a good subset from your original data set without losing the main focus, without losing the main thing. Then the second one, which I would talk more about, is feature extraction. In feature extraction, this involves creating a feature by combining or transforming the original features. You can combine from the example that I've given to us, from the house price example, you can actually combine some to get what you want. So that is feature extraction. And we can also say this will also reduce the data in a higher dimensional space to a lower dimensional space. Now, when it comes to feature extraction, we have so many methods, but the most commonly and widely used is called PCA, that is principal component analysis. We have others like linear discriminant analysis. We have generalized discriminant analysis and the likes. But the most widely used, which I will want to dwell more and talk about, is the PCA. All these are PCA. PCA is a library under sklearn. I call it sklearn library. So this library consists of 3 main modules for dimensionality reduction. There you have the decomposition algorithm, you have a manifold learning algorithm, and we have discriminant analysis. But the decomposition algorithm, that is where you find the principal component analysis that I want to talk about because of our time. And this PCA works on the condition that while the data is on a higher dimensional space, it's mapped to data in lower dimensional space. The variance of the data in the lower dimensional space should be maximum. If you could see from this little graph that is here, the variance between the PC1 and PC2 actually will help the result in the transformation, will help the transformation of the result. And you could see, you could export PCA from the library, from the sklearn.decomposition. You import the PCA, and this is the demonstration of how PCA is being used. Move to the next slide, please. Let's move. All right. So I want to briefly talk about some of the advantage and disadvantage of dimensionality reduction. Some of it helps in data compression and hence reduce storage space. All right. If you reduce the dimension of your data set, it will reduce the storage space. So also it reduces the composition time. It also helps remove redundant features, if any. All right. If there's any features or in your data set that are redundant, that are unnecessary, with the dimensionality reduction, you can remove it. It also prevents overfitting. One of our colleagues is still coming to tell us about overfitting. Dimensional reduction will help in overfitting prevention. Part of the disadvantages is it may lead to some amount of data loss. If you are not careful with the way you handle it, you might lose some sensitive data, which will not help your model at the end of the day, which will not give you a good result if you lose some sensitive and important data. That's part of the disadvantage. And important points to note in this, under dimensionality reduction, is that dimensionality reduction is the process of reducing the number of your features while you maintain the most important features as much as possible. And it can be done to reduce the complexity of your model, improve the performance of your learning algorithm, and make it easier to visualize your data. It helps in visualization of your data. By the time you have reduction you have the reduction in dimensionality, it helps in make it easier for you to visualize your data. And part of the other techniques I'm unable to talk about is singular value decomposition linear discriminant analysis, and the likes. Also, because of our time, I want to hand over to Mr. Joy. Thank you.
Okay. Thank you so much, Mr. Babatunde. Thank you for telling us about dimensionality reduction. And just for everyone's knowledge, that's Mr. Babatunde. If you have any questions for him about dimensionality reduction.
I don't know if I can just my presentation before I enter the gate.
Sorry, who is speaking, please?
It's
Hello?
Dr. Corey.
Oh, right. Okay.
Hello.
All right. So we were meant to take questions, but briefly, we'll quickly have Mr. Corey to take us through handling imbalanced data. All right. So you can go ahead, sir.
Thank you.
Hello, sir. Are you there?
Dr. Corey, I think he has network issues.
Yes. Okay. Whilst we are waiting for him, in that case, can we just go ahead and take questions then, whilst we're waiting for him to join us back? So if we have any questions, we can take some questions. Floor is open.
I'm not seeing the slide.
Oh, is that Dr. Corey back now? Oh, we're struggling with network. My apologies, everyone. I don't think he's in a place where he can speak properly.
Are you hearing me?
We can now, yes.
Okay, thank you. So I'll be talking briefly on handling imbalanced data processing. This is a form of pre-processing of data before model training. Next slide. Okay, for the it pertains to a data set where the distribution of observation in the target class is uneven. The example, if you can see the data represented up there, the fatal outcome will have 20/352, where the 20 is the number of people that died, and 352 is the number of people that survived. So as you can see, it is an imbalanced data simply. So the machine learning model become biased in their prediction as a result, and we tend to favor the majority class. So the challenges of imbalanced data are: one, the algorithm may get biased towards the majority class. The minority class observation look like a noise and can be ignored by the model. And also the imbalanced data set gives a misleading accuracy score. So there are methods that we can use to balance this data. One is undersampling. That means randomly removing samples from the overrepresented data. The second is oversampling, which we can do by duplicating samples from the underrepresented category. The third one is smooth, which is synthetic minority oversampling technique. We can do by generating synthetic samples from the underrepresented category. The next one is cost-effective learning that can be done by adjusting the weights of the misclassified samples. And the last one is the in-symbol techniques, which can be done by combining multiple models trained on different subsets of the data to improve performance. So in real life experience of a mortal and fatal outcome based on parameters is one of the examples of imbalanced data. Now we can develop a prediction model of the fatal outcome based on the antenatal clinic attendance, the ABGA score, the mode of delivery, and there are other parameters which are not represented because of the time. So the target class now will see that the fatal outcome is 20/352. Next slide. Next slide. Okay, so the first thing to do is to load the data. And I have written a code. The code is to read the data sets of which we have done, and this is the data set. The gestational aid at booking, the gestational delivery, the ANC, and we have seen both the maternal and the fetal outcomes. And also a code also reading to get out the fetal outcome, which is on this other side. And we have seen that the fetal outcome from the code is 1 is 20, the number of people that died is 20, and the number of people that survived is 352. Next slide. Next slide. Next slide, please.
It's
Okay,
on the,
so,
yeah, it's on.
Okay, yes, thank you. So the last thing we do is to balance the data. And the first one we do is upsampling, running this upsampling. And this is done by running this code. And we are going to use the smooth. And by the time you run the code, you are going to get 0 is now 352. 0, the number of people that died, and 1 is number of people that survived is 352. That is showing you that the data has been balanced and the machine learning will not be biased. We can also do downsampling by running this code. And at the end of the code, we are going to get 0 is 22 and 1 is 22. You see that the data is balanced and the machine learning will be able to do the training without bias. Thank you. I hand over to Joe.
Okay, thank you very much, Dr. Korea. That is highly appreciated. Knowing that you are on transit, we appreciate that. Thank you so much. So we'll now go on then to take questions. I saw a few hands up earlier. If you can just raise your hands again, I will quickly take questions before we move on. Any questions? Yes, okay. So I can see Mr. George Corey. Let's start with Mr. George Corey. Please unmute and ask your question.
All right. Thank you very much, Wisdom Plus. Your presentations were excellent. So I've got just one question. When the speaker who was talking about categorical variable encoding, when he was giving his presentation, he made us understand that that entails converting categorical variables to data so that your machine learning model will be able to understand them and operate with them. So while just reading around, I've always come across this term, object-oriented programming. My question, is there any link or relationship between categorical variable encoding and object-oriented programming? That's my question, please.
All right, thank you so much.
Let me respond to that.
Fabulous. Thank you, Dr. Sam.
Yeah, so object-oriented programming is when you go into software design. So, and then you model your program like a real life object. You understand? And when you model something like a real life object, there are so many things that goes into it. There is the naming, there is the features. For example, if you want to model an ATM machine, for example, the machine will have a location, you have the number of money inside it and all that. And then you also model actions. So what can the object do? Let's say, for example, we want to model an animal, let's say a dog. You know, a dog is a mammal, so it's a class. So it's under a class called mammal. And then we know that dogs have some features, like they have canine teeth, they have long mouths, most of them, and they have tail. And then you can talk about the color, different dogs, different colors. Some have black color, some have brown, some have white, and so many other things. And then you can also model what the dog does. So what are the actions? So dog walk, they bark, they sleep, and so many other things. So that's object-oriented programming. And then you use that concept to build a real-life software. But when we talk of machine learning, what we are saying is machine learning, the goal well, everybody listening, the goal of machine learning is to make prediction. We take some data, we do some features. That means what information can help me to make an informed decision. So that's the features. And then at the end of the day, you combine that features together with what you know, and then predict that this is what will happen. And we do it every day, but we just decide to formalize it and call it what we call machine learning. The good thing about machine learning is that just like every animal, we have carnivorous animal, for example, we have herbivorous, and we have omnivores. So omnivores means they can eat both plant and animal, and then carnivores can eat both, can only eat meat, animals, you understand? And then we have herbivores, which means they can only eat plants. So just the same way with machine learning. So machine learning has a kind of data it allows in which it can be able to use and transform. So for example, cow cannot eat anything other than plant. So, and that plant is able to convert it into meat and milk. So now in machine learning also, machine learning models that you can use to make prediction don't take any other data except numerical data. And we talk of numerical data, there are just two of them, integers and decimal numbers. So those are the only two inputs that a machine learning understands in order to make prediction. So if you have any data that is not a number, what the coding does is you have to convert it to a number, or else machine learning will not work. It's just like feeding a cow with meat. The cow is not going to eat the meat. You understand? And if it doesn't eat the meat, it's not going to produce the milk and the meat that we need. So the same thing with machine learning. If you don't feed it with numbers only, it's not able to make correct prediction. You're not even run at all, so you're not even make any correct prediction. The same thing with lion. Lion don't eat anything except meat. So if you give lion a grass, you just starve the lion. So the same thing with machine learning. If you don't feed numbers only with machine learning, it's not going to make a very good prediction. So that's just the summary. So software is a computer science is a wide field. So we have the software part, we have the data analysis part, we have the cloud and all that. So, but with respect to object-oriented, just like we said, is basically for software design. But this one is for data analysis and for us to make prediction. Remember, the goal is to make prediction. And then we compare the prediction with what actually is the real. So when we make prediction, we just don't make prediction at a go. What we do is we have the real value, we have the actual value that we want to predict. We just keep it aside and then ask the machine to make its own prediction. So when the machine makes its own prediction, we now compare what the machine has predicted to what we already know that it is true. So that's exactly how it works. And then we compare those two values, and that gives us a confidence whether what the machine learning is predicting is reliable or not. So that's simply the goal of machine learning. So now, based on that, we can ask, okay, for data we don't know, we have that confidence that this machine learning is able to make a very good or bad prediction. So that's exactly the goal of machine learning. I hope that answers.
Yes, thank you very much, Dr. Sam. It's your answer was clear. At least I was able to pick basically if we consider natural objects like normal living human beings, we can say, okay, those ones are like normal natural objects that have already been made by nature. If we want to use them for prediction in machine learning, then we assign categorical variables to them. But in programming, we can actually create objects, and that is object-oriented programming. So we can like create natural stuff by assigning, should I say, characteristics to them.
Yeah, characteristics, yeah,
Exactly.
Which is name and the actions they perform and the class they belong to and all that.
Yes.
Yeah.
So it's
And
like
also
yes.
And then there are other things like inheritance. So of course we know human beings can give birth. You understand?
Yes.
So you can have a father and a son, and they're both human beings.
Yes, I understand. Thank you very much.
Thank you, Mr. George, for that question. And thank you, Dr. Sam, for helping us to respond to that. We'll just quickly take one more question before we carry on with the program for today. So, Mr. Moses Achiloko, I can see your hand up. What's your question, please?
Well, thank you so much. It's mind-blowing what the wisdom class is doing.
Thank you, sir.
It is inspiring some of us. My question is from the same slide. The person that spoke before this, he was talking about converting values to numbers.
Yes.
And from what he said, the number is what machine will understand.
Yes.
What the machine will understand. But when he was converting it, like where he make mention of tomato, make mention of Dr. Sam, I'm seeing 2 there. But from what I understand, the machine language understand 0 and 1. Even though I saw 1 and 0, but these 2, like it said to what machine will understand. And I don't really understand that aspect.
Okay, Dr.
Okay, let
Sam,
me come in. Let me come in. Machine. When the machine you are referring to is the computer itself.
Yes, sir.
You know, computer only understand 1s and 0. So that 1 and 0 of computer is what it uses to make intelligent decision. So, for example, what you are seeing on the screen, the actual representation is 1 and 0. What you are seeing on the screen is 1 and 0. You understand? So so what you are saying is how a computer that we know when you start learning computer science, the first introduction to computer, they only tell you that computer understand only 1 and 0.
Yes.
So that's what the computer understand. But we humans, we don't understand 1 and 0. So we must find a way that we can convert that 1 and 0 to something we can understand. And that's what produce all these things that you're seeing on the screen, all these pictures, all these text, and in the core part of it, they are all numbers. But only the computer understands it. So we human, we don't understand it. So we find a way to create what we call an interface where the machine, just like an interpreter, you know, you go to a country, let's say you travel to France, for example, they speak French, and you want to communicate to somebody in France. What do? You introduce what we call an interpreter that will interpret. So you talk, and someone will interpret what you've spoken in English to French, and the person in French will talk back to you, and there will be an interpreter to convert what they have spoken in French into English. Do you get it? So what it means, so that interface or that interpreter, if you look at it, is the software and so many things that is installed in your system that converts that 1 and 0 into forms that you can easily understand. And also the same thing, when you type anything, the computer does not understand alphabets, does not understand pictures. So what it does is there's something also that converts those pictures, those texts, those alphabets to a number of 1 and 0 that the computer can understand and then execute what you want him to do. For example, you type your 1 plus 1. Computer does not know the meaning of 1 plus 1. So what it does is there's something that interprets that 1 plus 1 to 1 and 0, which the computer can execute, and then give the product, which is 2. And then that 2 is also 1 and 0, but you can't understand. So what it does is there's another thing that converts it back to the 2 that you understand. So it's a two-way process, and that's exactly how machine works. But what we are saying about machine learning is that the fundamental is that sometimes you get your data that are not in numbers. So when we say numbers, we are not.
Can everyone please mute themselves except Dr. Sam? Thank you.
Okay, so when we talk of machine learning, what we are saying is that you want to make prediction, we need to feed it some kind of data. Just like we need to feed cow grass in order to produce milk and meat. So in machine learning, you can only feed it numbers, and you only accept 2 types of numbers, which is what? Integers or decimal number. So it's only when it's in those 2 forms that it's able to analyze it and make prediction for you. Anything other than that, it will not even work at all. Just the same way that any food aside from plant, cow will not consume, and it's not good. In fact, if you feed with any other thing than plants, cow will definitely starve to death and you will not have any product. The same thing with lion. If you feed it anything other than meat, it will definitely not grow and will not produce anything. So it's the same process. So just understand those 2 different situations. I hope that clears it up here.
Thank you, Dr. Pham. I think from what you said now is that too is a representation, not actually from what he said now, like saying that to what computer will understand. I think that too is like a representation of the value that is converting to, like your name that is converted to.
It's a label. Let me use that word. It's a label. Yeah, it's a label. It's a label. It's a label.
All right.
So it's converting that text, which is tomato and all that, to something that the machine learning model is a machine learning model.
understand.
So that machine learning model is a mathematical equation. So when we say model, they are mathematical equations. I know mathematical equations only fit numbers. Even when you represent it by alphabet, for example, your quadratic equation, when you say x squared plus 3x minus 6 equals to 0, that x there is a number. You understand? So for you to get that 0, you have to that s has to be a number that will equate to, and then you do the arithmetic, and then gives you to 0. So the same thing with machine learning, or anything that feeds into machine learning, which is actually an equation in the real sense, must be a number for you to make a reasonable prediction. Anything other than a number, just like anything other than a number, if you feed it into a quadratic equation, it's not going to work. So anything other than a number, if you feed it into a machine learning model, which is an equation itself, just like quadratic equation, it's not going to give you the prediction or the outcome that you require. I hope that clears it. Yeah.
Thank you so much.
That is clear now. Thank you.
All right. Okay. So thank you, Mr. Moses, for your question. Thank you, Dr. Sam. Right. We are fast spent for time. Mr. Olaolu, I can see your hand up. However, we will take your question along with the next set of questions. So we'll just have a quick 5 minutes break and we'll come back for the next set of presentation. So we'll come back at exactly 1:10. I know for those in Nigeria, that will be 2:10. Okay. So I'll see us in 2:10. Thank you, everybody. Okay, so I believe we have all had a good 5 minutes break, hopefully, and we should have started coming back now. Welcome back, everyone, to the presentation set 2. We have all done a great job listening to my colleagues talking to us about problem definition, data collection, EDA, data cleaning, feature engineering, encoding of categorical variables, dimensionality reduction, and handling of imbalanced data. Those were the things we've heard in our presentation set 1. Now we are moving on to the presentation set 2, where I would like to start by inviting my colleague, Mr. Adi Danlami, to speak to us about ensemble learning, bagging, and boosting. Mr. Adi, the floor is yours.
All right, thank you very much, Sister Joy. Okay, my name is Adi Danlami, and I'll be presenting on ensemble learning, bagging, and boosting. So before I go into what I have here, I would like us to have this scenario. Suppose I want to build a house, and I have 5 friends that have already built a house. So I want to ask my friends, like, what kind of house should I buy? Now, the concept of ensemble learning comes into play here, because I could have just called one of my friends and asked him about the house I want to buy. But that my friend could be biased, or he could give me some result that maybe it's not what I want. But if I go about asking all my 5 friends about this house that I want to buy, and then I gather all their input, I can now make a decision. So this is the concept of ensemble learning. 1, ensemble learning is a machine learning technique that aggregates 2 or more learners, e.g., regression models, neural networks, in order to produce better predictions. Also, ensemble learning usually produces more accurate solution than a single model would, just like in the case of my friend. One of my friends can only give me all he knows, but if I have 5 friends, I have more information about the house I want to buy. Also, ensemble learning method is applied to regression as well as classification. Ensemble learning for classification creates multiple regressors, that is, multiple regression models such as linear, polynomial, etc. Also, ensemble learning for classification creates multiple classifiers, that is, multiple classification models such as logistic or decision tree, or k-nearest neighbor, or support vector machine, and so on. Let's go to the next slide, please. Now, one of the techniques in ensemble learning is bootstrap aggregating or badging. So you can use it interchangeably. Now, at the first step, multiple learners models are generated. These models are generated using same learning algorithm with n random observation of m subsample of the original data set using bootstrap sampling method. This second step is aggregating the result generated from this model. Well-known methods such as voting or averaging are used for this purpose. Like in the diagram I have here, suppose I have 100 data set or sample. Now, for me to apply ensemble learning, I will use bootstrap sampling, which is sampling with replacement, which means at each sample, I might have an observation or a data point. I might pick it more than one or multiple times because I am sampling with replacement. Then I will run these 3 models on it. But for ensemble learning, we can have more than 3. We can have n samples to make their own prediction. Then at the end, I will collect their prediction and then average it and see the best result. Or sometimes we could just use a voting technique. We'll just create a model that has the highest vote. That's this model that we'll pick, and that's the prediction that we'll use. So let's go to the next slide. Now, another techniques in ensemble learning is called boosting. Now, in boosting, it is kind of similar to badging, but a little different. In boosting, it tends to change these weak learners to strong learners. That is, after creating your samples, and then you run the first model. This first model can create some error. After making its own prediction, it might have some error. So in boosting, we take this error created by the first model, and then we feed it into the next sample for the second model to train on. So this second model have the advantage of like developing from the error of the previous model to make better predictions. And also this second model can also make its own error, which I indicate by this variable alpha. You see alpha 1, alpha 2, alpha 3, because in this case, I'm using just 3 models. So each of these models, at the end of their training and prediction, they will generate their own error. So in boosting, we aggregate all of this prediction with the errors in some way to create a more meaningful result. So these are the techniques of ensemble learning. And over the years, ensemble learning has proven to be more advanced, and it produces better results than just using a single model. Thank you.
Thank you, Mr. Adi. Thank you so much for that. And hopefully we'll be celebrating a new house with you soon. Okay. Right, that's Mr. Adi. If you have any question about ensemble learning, bagging and boosting, we can write that down, and we'll now move on to Mr. Ayobami to talk to us about supervised learning, regression, and regressors. Good afternoon, Mr. Ayobami.
Good afternoon, Joy. Thank you, Mr. Hadi, for that. All protocols duly observed. I hope you can hear me.
Yes, we can.
Okay, so straight into supervised learning, regression, and regressor. Supervised learning means teaching a machine to make predictions by showing it examples with answer. For example, if you show a model house sizes and their prices, it learns how the size influence the price. And once trained, it can predict prices for new houses. So like we said, regression is a branch of supervised learning that deals with predicting numbers. And application of regression includes predicting house prices, like my past instructors have said, stock market forecasting, as Joy has also said, and also analyzing trends in data. And this case, it finds patterns like how sales increases over a period of time. So regression is used to predict numbers. Our focus will be on linear regression. And linear regression is the easiest and most understandable method for predicting numbers. It assumes a straight line relationship between input, which is the cost, and output, which is the effect. Like we said earlier, it's used widely across different sectors. For those in the real estate, for those in the stock market, regression is used almost everywhere. Can we go to the next slide, please? So, linear regression model. Dr. Sam was explaining something to us, saying that there is a mathematical formula for all these models. So for linear regression model, there is a mathematical formula which can be seen on the screen. The screen says linear regression assumes a linear relationship between input X, like I said earlier, input X, which is the cost, and output Y, which is the effect. So the mathematical expression is Y is equal to Y equals beta 0 plus beta 1X plus epsilon, where Y is the thing you are predicting. So in this case, we want to predict the price of a house based on several factors. So Y is going to be the house price, which is what we want to predict, and X is the factors that are affecting the predictions. That is to say, the size of the house, the number of rooms, number of toilets, and vice versa. Okay, so beta 0 is the base value which starts from when X equals 0, and beta 1 is how much Y changes when X increases by 1. That's the mathematical formula. And then the epsilon is the error term. And the objective here is to minimize the mean squared error to find the best fit line. That is to say, is to find a way such that it can minimize the error it gives as the output when we train the models and and input data into them. So a recap, linear regression is just like drawing the best straight line through a bunch of dots, data point on the graph, and the goal is to predict where future dots might fall based on the line as seen on the screen. The model works in such a way that you tell it the size of the house and uses the line to estimate the price. As is to say, you tell it, you give it the conditions, the classifications of whatever, what have you, and then the model predicts an outcome, which is going to be the price. So the formula helps the model figure out what the line will look like as in the graph. Next slide, please. We have the machine learning pathway. And as my predecessors have also explained, we have, as it says here, the real world, where we get data from, we collect the data, we store the data. Then the next step, you clean, organize data as the knowledge class already doing that using Excel and SQL, PostgreSQL, and Python. Then you explore data, exploratory data analysis, you get to analyze and then use machine models to predict. So of course we have the Jupyter NumPy pandas that are used for all of these purposes. So yeah, we have something that I would explain to have a better understanding. We can see there is a chart here which shows the area measured in meters squared, the bedrooms, and the price. This is more like the data we have and what we are going to use in training the models. Can we move to the next slide, please? So for this data, like we said earlier, we have the X and then we have the Y axis. The X axis being the factor affecting the prediction, and the Y axis is what we are trying to predict. So we call them X, which is the futures, and Y the label. Y is what we are trying to predict, which is the price, and X are the factors, which includes the area, the bedroom, and the bathroom. So when we have the data, of course, we label them. We have the X axis and the Y axis. Then we kind of form or have a split, which we have a training data set and we have the test data set. And as you can see on the screen, we have the X train and the Y train. That is the X, but we have what we are training the data with and the outcome of the data. So this is a known data, and we want to use this known data to predict the price of every other type of, let me just put it in this way. We have, for 200 meters square, and 3 bedrooms and 2 bathrooms, the price is 500,000. But we want to know what the price of 100 meters square would be that has 1 bedroom and probably 2 bedrooms. What would that give us? So we have to train the model with this data, which is above. And then we now test with the one below, which is 180, 1, 1, 210, 22. This is what we use to test to see how accurate this model, the mathematical expression will be. So we give it the X train and the Y train, and then we test with just the X test. But we know that for 180 meters square with a bedroom, 1 bedroom and 1 bathroom, we know that it's 400,000 based on what has been happening in the past, based on prices from the past. But we just train it without, we train the model without giving it the price. Just we want it to calculate the price for us so that we can see how efficient the model is. So we train it with the X text and see what it predicts for us. So if we can go to the next slide, we can see the prediction and see the error or the margin. So we can see from the prediction, after training the data set, giving the model data to train with, we can see that its prediction for 180 meters square with 1 bedroom and 1 bathroom is $410,000, which our actual price that we sold in the past was 400,000. I hope we can understand. So we also tested it 210 meters square with 2 bedrooms and 2 bathrooms. They found out that its prediction was $540,000. But apparently, the price in which it sold in the past was $550,000. So the margin is not that wide. And so we are able to test and impute, give it more, query it more and more to know the price of specific features of the house in the future. And that is what the linear regression model machine learning is used for. So we have something below which is the X and Y data, the training data set. So the X and Y data, the real data, then we split it in we give the model training data set and let it work with it, let it learn the pattern, and also we test it. And then it fits and we feed and train the model with the data. And then we have an evaluation and evaluate performance. So we have a prediction of what the training model has given unto us. All right, so I would like to invite Mrs. Okoro to explain the last slide that she mentioned within the slide as well. Thank you very much.
All right, thank you so much, Mr. Adi. That was really helpful. Sorry, Mr. Ayobami, that was really helpful. Okay, so even though we had to push through your network, thank you so much. Now, we will have Mrs. Ozioma to talk to us about unsupervised learning. Miss Ozioma.
Good evening, everyone. Can you all hear me?
Yes, we can.
Okay. Good evening, everyone. My name is Ozioma Koronko, and I'll be talking about unsupervised learning. Now, I need to look back to what Mr. Ayobami talked to us about initially when one of the slides shows that supervised learning focuses on making predictions, whereas unsupervised learning helps us see trends and clusters in our data. So we want to think in terms of what is the difference between these two. So I'll use this slide to explain it, then we'll have some other slides to give us a real life scenario of how it goes. Now on our slides here, we'll see a bunch of animals on the top left, and we don't know what to make out of it because it's like, what do we do with these animals? Now we look at it and then we pass the data we have through an algorithm. And what the algorithm does is that it processes the data and gives us an output. And by the time it gives us an output, the output comes in forms of clusters or groups. Now, let me use this scenario. Imagine that you come into a room full of balls. How do you group these balls? The first straight up thing is to look at the colors of the ball. So let's say you have a group of 100 balls littered in the room, and you think in terms of, okay, there's blue, there's red, there's yellow, there's pink, there's purple. And you get the blue, put it in a bucket, get the yellow, put it in a bucket. So unsupervised learning does not make predictions, but rather it discovers unique groups in our data, and it helps us recognize those groups in our data. So one beauty of unsupervised learning is even for a data that is not structured, that is not labeled. Mr. Ayobami talked about features and labels, in which we see the features are like independent variables, and the labels are things that are somehow affected by these features. For unsupervised learning, we have unstructured data. I'll show us an example later on. So how does this happen in machine learning? There are algorithms for unsupervised learning. There are the clustering algorithms, of which we have k-means clustering, hierarchical clustering, and then DB-scan. I'll be focusing more on k-means clustering. Another approach to unsupervised learning is dimensionality reduction. And one of my colleagues had earlier on explained the PCA, that's principal component analysis, which basically enables us to reduce the number of components so as we can focus on the ones that give us the most out of our data. so that we can be able to make sense of the data. So how do we evaluate how do we evaluate the performance of our algorithm in unsupervised learning? We use different plots to see. Now, because we're not making predictions, we want to be sure that the number of clusters we notice are actually accurate. So we use the elbow plot, which helps us identify the accurate number of clusters or groups in our data. There's the Kalinski-Harabas index or the silhouette score. Now we'll talk about the real-life application of unsupervised learning. You talk of customer segmentation. We give an example. Let's say you where I live, you have malls and they have registration. How do they group these customers? Sometimes they group it based on age, in which they find out, I mean, like they can determine, okay, this person is middle-aged, so maybe he has a family, and then so this becomes something with which they group the customers. You think in terms of anomaly detection. How does your bank know that your account has been breached or that your debit or credit card has been breached? It's because they notice something odd about a particular transaction, and then they call your attention to it and stop the card immediately. We talk about taxonomy and genome analysis in biology. The example I have later on actually deals with this. We think in terms of in biology, in classification, we have the different, okay, toward the end of classification, we have the family and then the species. Within each family, you have different species. So the example I'm going to use later on gives us data from a particular biological family, and we want to look at, is it the same, or is there something different? Are there groups inside this particular family? And then we look at recommendation systems. My colleague Joy made mention of things like your Netflix or Spotify. How do they make their recommendation? Think of image analysis, social network analysis. These are real-life applications of unsupervised learning. Can we get to the next slide, please? Okay, so we talked about unstructured data. Now, if you look towards your top left, we see a table, well, a representation of a table. On it, we see things like sepal length, sepal width, petal length, and petal width. And we see a bunch of numbers. Now, if you're like me, it makes no sense. What does these numbers mean? What does it represent? So unsupervised learning helps us to make sense out of these numbers that on the surface level look like a jumbled bunch of numbers. So how do we go about it? Usually, as always, in Python, you import the libraries that are important, and then you load in the data. So we run the head to see the first 5 rows of our data. Then after we've seen it, the next thing we want to see is what is the spread of our data? And so we use visualization to see a spread. In this case, I used a pair plot, which basically charts 2 columns against each other. So what we see on the right is basically a distribution of our data. And then one thing, the first observation is that it looks as though there are just 2 clusters in our data. Almost all the charts here has 2 clusters. Well, we'll find out, because K-means clustering, the methodology we're going to use, expect that you supply a number of clusters, a run-6 model. But then because of its own way of evaluating the performance, you can check to confirm that your visual observation of clusters is accurate. So when you run that, you can also now adjust or rerun your code, rerun your model with the appropriate number of clusters. So can we go to the next slide, please? So we have 4 columns in our data. And the next worry is, do I need all these 4 columns? Are they all effective? So what we do is to maybe run a correlation to see the ones that are most effective or that are most connected. And from our charts here, we can notice that petal length and petal width seem to be the most correlated. So we are going to use it for these 2 columns for analysis. Looping back to what Mr. Babatunde discussed earlier on, my colleague Mr. Babatunde, when he talked about dimensionality reduction. This also is a good case for dimensionality reduction, a situation where your data has so much information and you want to know which ones can give you the best outcome so that you're not encumbered with too many information and then lose out on the core issue. So in this case, with this, I was able to narrow down to this two columns to give me the best outcome. Can we go to the next slide, please? So what do we do? Remember, I made mention of the elbow plot as something that helps us evaluate what we have in our data. So now the elbow plot here gives us, can you circle at the joints at the elbow, just over the 3 on the chart? Now, the elbow plot here tells us that 3 here is the hinge of the plot. Thank you so very much. This point, that's like, you can imagine holding out your elbow, the place where your elbow turns downward, from there turns downward. That's your hinge. So the elbow plot here shows us that we have 3 clusters. That means what we saw visually was not accurate. So this helps us now. Now we can go and re-execute our model using 3 clusters as the number we want to use to check for clusters or grouping in our data. Can we go to the next one, please? Next slide, please. Thank you so much. So now that we know that we have 3 clusters, we now rerun our model. And here we have a chart of what our model shows. The color coding is to help us find out that what on the normal eye we could see as just 2 clusters was actually 3 clusters. We see the green, we see the black, and we see the blue. And then the red dot in the middle is the centroid, is like placed at the center of each of the clusters. So basically, this is one way we can use unsupervised learning, even though this is quite a simple showing. But with this, there are so many other steps like feature engineering used to process the numbers and all that, which has been explained before. But what I wanted to show is how unsupervised learning works in real life. So I think that's what I have for unsupervised learning. Thank you.
Well, thank you so much, Mrs. Ozioma. That was a wonderful one. Thank you very much. Now we will move on to ROCAUC, and that will be given to us by Mr. Oladele. Good afternoon, Mr. Oladele.
Good afternoon, ladies and gentlemen. Hope we can hear me clearly, please.
Yes, we can.
Thank you. My name is Oladele Adewumi, and I'm here to speak much about ROCAUC in machine learning. ROCAUC is an acronym which means Receiver Operating Characteristics Area under the curve. You can help me to the second slide. Thank you. So with this, we can say why is ROCAUC important. ROCAUC is important in the aspect of model comparison. You might have heard from all my colleagues talking about model. What ROCAUC do basically is just to test the efficacy and performance of each model being designed. So with the ROCAUC, we can measure the model comparison. It can give also robust to class imbalances. You know, some of my colleagues talk about maybe having a wider data set, imbalance in data set. We can use ROC to find a robust class imbalances for them. And with the ROCAUC, we can choose different thresholds. It allows threshold selections. And also with ROCAUC, we can use it as a diagnostic tools in the hospital, in the banking sector, or in the security department, just to test the efficacy and the performance of the model they are using in prediction. Now, the names imply a curve. We test our prediction, performance of our model through this curve that we can see here. On the right-hand side, we see true positive rates, and on the left hand, on the x-axis, we have false positive rates. Our question is, how do we get this all this value to plot the graph? We got it through confusion matrix. Don't mind the name. It's confusion. So what is it for? It's a kind of a platform that allows to actually predict compare the prediction and the actual value of our model, of our classes in our model. Let me give an example to explain it better. Maybe, for example, I have in my mailbox, I want to test some of the mail, which one is a spam and which one is not spam mail. So I can say maybe a spam mail, my mail, the mail in my box is a spam. Let me say it's positive. But if not spam, let's make it a negative. I want to predict a mail in my box. So the actual one now, I have a positive and a negative class, which is a spam and not spam. So in my prediction, if my prediction happened to be positive and my actual is also positive, at that moment, I will generate true positive. That is why you see the first red square inside. If my prediction is actually negative, but my actual is negative, and my addition is giving positive, my actual is saying the mail is not a spam, and the actual and prediction is telling me it's a spam. I have a false positive. And on the other side, if my actual is telling me the mail is not a spam, and prediction is telling me it's not a mail is not a spam, prediction is telling me it's a spam, I have a false negative. Likewise, the other one, where I will get the true negative when the mail is actually telling me it's not a spam and the prediction is telling me it's a spam, I'll have a true negative. When we collect this under a threshold, because there must be a threshold before you start knowing which class is positive, which class is negative. Under a threshold given, by which any value that is beyond that very threshold, you can easily classify it to either the positive class or the negative class. So after collecting all this, I can now come to get my x-axis and y-axis. I'm talking about a model that was being designed. I want to test its performance. So I will get my true positive through this formula you see underground. The true positive TPR is equal to true positive, the red column you see there, all over sum of the true positive and the false negative. And I'll get the down below the false positive, which is equals to false positive, which is the second column of the red, all over sum of the sum positive and the true negative. You can help me to the next slide so that I can explain, I can easily interpret this graph that we see. Yeah, interpretation of ROC AUC. Basically, the graph you see here is a very simple graph to understand with our basic secondary school understanding. The graph is where the AUC come. You know, I told you the other time, AUC from that acronym means area under curve. Why ROC means receiver operating characteristics. The length, all those graphs that you see there, they're actually ROC. Why the area covered by those graphs, they are the AUC. And you can see from the graph, you can see I put the actual value of the AUC for each of the line graph that you see there. You can see there's the one that gave SOVA score, gave AUC score to 0.79, and so on, and so forth. The other graph that I put here, you can see the AUC and their value. So categorically, we have 4 sets of AUC, which determine whether our model is performing well or not. Remember, all those graphs represent a model. So if your AUC is equal to 1 under your model, a line, a graph, you calculate the area under that graph, you get 1. It means you have a perfect model. A perfect model. Your model is learning well, it's giving a better result, it's giving a better prediction. And that one moves towards the edge. For example, let me give us this instance. There's a single lane that divides the two sides together. Divide them from each other. That single perfect line is when your model, when your AUC is equal to 0.5. And with that, I can easily just explain to us what AUC means. If you look at that single lane, you see like it gives us a perfect right angle triangle. And from our basic secondary school calculation, what is the area of the triangle? Area of a triangle is half base times height. Our base here is 0 to 1, which is 1. And our height is here from the y-axis is also 0 to 1. So if you calculate the half base times height, you get your half as your area. So that perfect line that divides that rectangle into half is where our model is 0, is 0.5. And it gave us a random, it means our model is guessing. It doesn't know whether it's actually learning well. Is it moving? It's just guessing, it's under guessing. So to have a very good model, to move towards the perfect model, your line of the graph has to be the one that has yellow, red, green, and blue. It's moving above the random guessing. And to have the one poor model, that is the model that are performing poorly, that one below, come to the other graph, man. That golden, that very point where your stuff, that line is performing below the average. So now with the understanding of our AUC, we can see that when your AUC is between 0.5 and 1, you have the best performing model. And when it's below 0.5, you have poor model. And with that, we can see that with the help of the AUC and ROC, AUC, we can see that we can tune our parameter of the model. When model is not performing, which one is performing, which one is giving us, which of the parameter we need to tune to get a better performance. We can tune it. The threshold at which we calculate our TPR and FPR, we can also adjust it to a very good, to get the very better class, to make our model to distinguish between the positive class and negative class better. And also, with the help of this graph, we can notice that we can select the best performance model. You can see that as the model is moving towards the other yellow in the second graph is moving towards 1. No, the other graph, is moving towards 1. So we can select the one that is performing. When you notice your model is not performing well, you can easily tune your parameter. Those are the uses of ROC AUC. You can use to monitor. And in conclusion, we can see that ROC AUC is a powerful metric for evaluating the performance of binary classification model. And its ability to handle class imbalance that I mentioned the other time and provide instant into models in discriminative power make it a valuable tool for machine learning practitioner. And lastly, we can understand that the understanding of the ROC AUC and interpretation of AUC value that I made mention earlier on allow one as a machine learning practitioner to make informed decision about models selection, which model do I want to go for, how is it performing, and what do I need to tune in my model to get optimal results and deploy the model. Thank you. God bless you all.
Thank you so much, Mr. Alade. That's a wonderful one, helping us to understand the best model we can select according to what we have done with our data, and that's really beautiful. We are drawing close to the end of this. Thank you everyone so much for your patience. We just have Mr. Ahmed Lawal to help us to round this up by talking to us about overfitting and underfitting. Because if we remember, Mr. Babatunde mentioned earlier how to prevent overfitting. But what is overfitting and underfitting anyway? So this is where Mr. Ahmed Lawal comes in. Good afternoon, Mr. Ahmed.
Thank you, Madam Joy. Good afternoon, everyone. My name is Ahmed Lawal. I'll be speaking to us on overfitting and underfitting. The two concepts are possible outcomes that we usually encounter when we do prediction in machine learning. Like Dr. Sam earlier explained, machine learning is about creating a model that has learned the pattern in data sets and can make prediction based on the pattern learned. And when we do prediction in machine learning, there are 3 possible outcomes that we can have: overfitting, underfitting, or a good fit. So a good fit is the ideal situation that we want. It has done the prediction the way we wanted it, accurately or near accurately. However, underfitting is a situation whereby a model or algorithm is not able to learn the pattern in the data set properly, and in such an instance, it's giving us a poor performance. However, the reverse, which is the overfitting, is when the model gives us the illusion that it has learned the pattern in the data set, where in fact it has only memorized the pattern. It does very well in training, and when you now introduce it to a new set of data, it performs poorly. To further throw more light on this issue, I would draw up two scenarios for us: a tailor and an apprentice. A tailor has three apprentices. An apprentice that he trained, one has sewn an oversized cloth, I will regard that as overfitting. The other apprentice has sewn an undersized cloth, I will regard that as an underfitting. And the third apprentice has sewn a good fit cloth that fits perfectly well on the client's neck. So in such instance, we don't have issue. So when we have an overfitting situation, when the person has sewn an oversized cloth, so the quick remedy that the tailor can do for the apprentice is to cut out the irrelevant portion of the cloth so that it can fit perfectly well on the client's neck. So I can call that feature selection. So cutting out the one that is not relevant, so you exclude the irrelevant ones. So the other thing that I can do to correct the situation is to expose the apprentice to different kind of cloths by teaching them different pattern so that they can sew for a tall person, a fat person, and such like that. So in such instance, it can help that apprentice that has sewn an oversized cloth. For the one that sew an undersized cloth, the remedy that I can do for that person is to now give him more cloth to adjust the cloth so that it can fit perfectly well on the client size. So that's why we say you're increasing the number of features in the data set. So the other issue that I can also do for this person is to give him more time to learn. In that case, it's going to increase his training time so that I can learn the pattern in data very well, can learn the technique of sewing very well, so that next time we sew a better cloth for our client. The other situation that it can do is also to be exposed to sewing different kind of cloth for with the apprentice so that I become more experienced. The second scenario I would like to use to shed more light on this issue is a mathematics teacher and a three set of students. So we have an overfitting student, underfitting student, and we also have a good fit student. During our training, the mathematics teacher, he gave the students AOC, area of concentration, list of topics that's going to come out during their test or their quiz. And now he also go further to solve some set of mathematical questions for them and give them the solution. So the overfitting student, during the training, he memorized, rather than learning the technique and the concept of solving that mathematical solution. During the training, he memorized everything and does la crème la pour. So I gave the teacher the illusion that he is very good at it. So he scored 97%. If you see the example table, the training score, during the training quiz, he scored 97%. Now, when we introduce the real test to him, he now scored 54%. So, and the second set of students, the underfitting students, during the training, he has shown that he did not really learn all the concepts. He has only mastered a few of the concepts. And during the quiz, he didn't perform too well. When we now do the training, they introduce new set of questions. When we want to do actual tests, they introduce a new set of questions to the student. Because the student have learned, I say, okay, maybe he learned 2 or 3 topics very well, irrespective of the type of question they throw at him, provided you are still testing the same concept, he was able to still do fairly well and gets the remaining. That's why he scored 59% in the first instance during their quiz, and the retail he scored 57%. While the third type of student actually did very well because he learned both the concepts and he also learned the steps that he is going to take. He scored 96% during the tests, during the quiz, and he also scored above 90 during our real test. So these are the 3 types of scenarios that we have. So the good fit is what we actually aim at every time. I've already explained the solution to it. My next slide, please. Thank you, Madam Joy. So if you look at the first chart beside on our screen, the underfitting students, we have a cross. We have something like a cross, not really cross, like when you mark something wrong. So this is the these are the data points. The underfitting student gave us a linear data point because he didn't really understand the relationship or the pattern in our data set. Whereas the appropriate fitting or the good fitting student was able to master all the technique and the key concept, and he was able to give us the accurate data point when he was trying to replicate what he has learned. So all these zeros, we call it noise. They are not supposed to be, it's not what you should be focusing on. Whereas the overfitting student was learning both the data points and the noise. The noise, we don't have anything to do with it. It's the data point that really matters for us when we are learning pattern. So he learned both the noise and the data set. He does the la crème la pour. So it's not a situation where we want. So I'll quickly, the second chart is telling us about the point where we want to be as when we do prediction. We want a situation whereby we are not overfitting or underfitting. We want a perfect fit. However, in reality, it's not possible for us to have a perfect fit. The perfect fit is the bottom of this green line. So, and however, anywhere within this white zone that is in between the purple lines is a good fit for us. If we are able to achieve that, that means in that place, you are able to minimize the bias and the variance. What do I mean by bias? Bias is simply the training error, margin of error between the actual and the predicted value when you are doing your training, when you are applying your model to your training data set. Whereas variance is test error. This is the margin of error between the actual and predicted value of data when you are applying the data, the model to a new set of data. So every point in time when we are doing prediction, it is very important that we have a best fit model which tries to minimize the error of overfitting, the bias and the variance. So in conclusion, I will say it is very important that the model we create is reliable, because to avoid huge loss due to that prediction error, it's very important that we predict accurately and have a good fit model anytime we predict. So thank you for listening.
Thank you so much, Mr. Ahmed. That's a really wonderful one and a lovely way to round up everything that we have been speaking about so far. So we are fast spent on time. I will quickly take one more question now before we then have Dr. Sam probably help us with the question and then also give his own final remarks. So I can see a hand up, but initially we had Mr. Olaolu Olufemi. Is he still here to ask his question? Mr. Olaolu Olufemi.
Yes, I am. Good afternoon. I think the other presentation has attended to most of the questions I have.
Oh, fabulous.
The other one just pending is on the data balancing method.
Yes.
I wanted a clarification on the pros and cons of balancing methods, especially when you are dealing with making inference from your the results of your models into live scenario. What are the pros and cons of balancing methods? Thank you.
All right, thank you very much. That's a good question. Pros and cons of balancing method. Okay, we'll come on to your question. And the next person I can see here is Mr. Dayo Akinsono.
So much. My question is on the linear regression model. There are rules for choosing the training validation set when you want to make your prediction. And secondly, for prediction accuracy in machine learning, this influence the prediction accuracy, or what are the let me say, what are the rules of thumbs in terms of choosing the minimum sample size for your prediction in machine learning? Thank you.
Okay, thank you very much, Mr. Dayo. So your question is asking about the rules of thumb in how to decide in the appropriate model in your machine learning. And for Mr. Olaolu, it's the pros and cons of balancing. Okay. Please, can we have Dr. Sam, sir, to help us with the questions? Thank you, sir.
Yeah, let me start with the last question, the rules of thumb. The rules of thumb is that your training must be more than your test. So it's just like when we are studying for a course, you have a lot of tutorials more than the exam questions. So the reason why we have a more tutorial questions is because you're able to see a variety of options of different scenarios and all that. So you may do like 50 tutorial questions, but in the real exam, you only do maybe less than 10. So that's typically the rule of thumb. So you need to be able to train as much, just like you driving a test and you are preparing for a driving test. We'll have done a lot of lessons that span months, but the actual test is just less than an hour. So that's exactly how it works. So you need a lot more data to train your model and then less data to test. So the reason being that you're able to have more experience, let me use that word, so that when you see a real life scenario, you have a lot of experience to deal with whatever the scenario may be. Then the other bit is, I think is on balancing, right? So on balancing, you see, in real life, let's take, for example, a woman giving birth. It doesn't matter which country. We all know that majority of women that give birth survive at childbirth, or children that are giving birth, you understand? Let's say in any country, the people that successfully give birth are the majority. So it doesn't matter which country, whether it's in Africa or Europe or whatever. It's just that the number differs. So let's say in Nigeria, for example, out of 100 women, let's say 70% will always give birth successfully. No, it's small, it's greater than that. Let's say 85%. So we know that for every time, 85% of women will give birth successfully. Now, there's always 15% that have complications, sometimes leads to death due to the nature of our health services and all that. Now, if you have a machine learning model that just say any woman that is giving birth in Nigeria, the child will survive. You know that model will be 85% accurate, but it's not useful. So that model is 85% accurate, but it's not useful. So what we need to do is we need to identify those particular women that is at risk, or those risky birth process that the child is likely to die. And that's where machine learning comes in. And so what machine learning comes, and the useful part of machine learning is the ability to predict those women who are vulnerable and those child who are likely to die at childbirth. And so what happens is the machine learning will be able to predict that this woman will develop complication. So the little medical facilities and personnel that we have cannot be tailored to service that woman. And those we think we don't have complication, they can give birth natural. Of course, we know people give birth at home, people give birth in the hospital, people give birth in buses, and they no complication. That's majorly what happens in real life. But we know there are people who develop complication that needs, for example, you need to operate on them, perform CS and all that. So our machine learning model will only be able to identify those ones that will need possibly CS or a very critical medical attention. So that's the essence of machine learning model. And so when we develop that model, we now say, okay, we don't want a situation, it's good if our machine learning model says this child will develop complication. But at the end of the day, it does not develop complication. You know, it's a good model. But we don't want a situation where the child will develop complication and the machine learning model will say, no, the child will not develop complication. That's a very wrong. So that means somebody will know that is at risk. The machine learning model is telling us not at risk. So we'll not give him the necessary attention. And that's what we're trying to avoid in machine learning. So that's just in a nutshell, the whole process. Then the other aspect with balancing, the reason why we do balancing is to avoid bias. That's just why we do balancing. Just like I said, we know that if you have a data set and you have 90% is positive and only 10% is negative, the machine learning model can just say all will be positive and it will be 90% accurate. but it's not a useful model. So what we do is we make it 50-50. When we make it 50-50 and we get 90% accuracy, then we know that the machine learning model has understood the problem correctly. But when is it the other way around, like it's skewed to one particular aspect, then that's when people become biased. Just like everybody has an individual bias, but the best way to avoid this is to randomly pick those particular data. And that takes me to the last question that talks about randomness. So when we select the training and the test, we select them randomly. So there's no pattern to how we select them. And the reason why there's no pattern is to avoid bias. So we select, maybe you can select number 1, then go and select number 50, go and select number 200, like that. That's how we select the percentage of the training set. And then we go and do that random picking also for the test set. The reason being that the data we are selecting doesn't have a pattern in respect to how we select them. So the machine learning is able to really understand the features that is necessary to make accurate prediction. And then there are other aspects which they've not mentioned, which is regularization and all those things. But it all goes to ensure that there is no bias whenever you are using your machine learning model to make prediction. I think I've answered all the various questions. Yeah. So and that I will, by God's grace, I will just round up. This presentation you've seen are 3 months of work that we've done in Wisdom class, which I possibly spring roll together with Pastor Gibson and all that. And so what typically happens is, this is the part 1. So this is the part 1, and we just let them come and show us what they've learned about these 3 to 4 months that we've been dealing with Wisdom class. We normally hold our lectures on Sunday between 4 to 6 p.m. And then in the second part, hopefully by the grace of God, Pastor Gibson will come and explain, is when we talk about artificial intelligence. You know, we're all talking about machine learning. We're not talking about artificial intelligence that you people hear about. There's natural language processing, there's cloud computing. So those particular one is the part 2 of this particular training, and that will come up subsequently. But this is just what we think is the introductory part, which gives you the fundamentals, the foundation to machine learning, artificial intelligence, and all other aspects that builds on it. And then finally, for those who are thinking of coming to Wisdom class, the good news is all the people that presented today were from knowledge class. They're all of them are from knowledge class. So it is a progress that we made. See where all of us are starting from and see where they are at the moment. And the reason being that the reason why we do the knowledge part is because that's where the data processing, the data exploratory and all that, that's where you need to learn it. Because you build on that skill of data exploration, data cleaning, data pre-processing, because to use in machine learning. Because in machine learning, the quality of the data matters. So if you don't have a clean data, you not get a clean prediction, you don't get a good prediction. And that's why knowledge class is focused more on your ability to extract data, process them, and make it as clean as possible for either exploration or visualization or whatever. But by the time you come to Wisdom class, we now use that clean data to make prediction. And so that's just the progress about it. So when you're in knowledge class, you do the data cleaning, you do the data processing and all that, but you only do it to do visualization. You understand? To do visualization and all that. But when you come to Wisdom class, you still do the same thing, but this time around, you make predictions. And that's where the difference comes in. And you see, all the things they've done today is all about predictions and how to make your model more accurate. And that's exactly the way we normally do it.
Thank you, Dr. Sam. So we're going to have Pastor now to come on and just give us his remark as well. And after Pastor, we'll then finish off with just 2 minutes to quickly read the messages that some of the people in the knowledge class have said to us, the Wisdom class students, because I would love my colleagues to also hear about that. So Pastor, please, let's have you, sir.
All right, thank you very much. What I want to say is that we should give our applause to, first of all, to Dr. Sam for definitely taking the truth to teach and bring us on to this point. Let's appreciate him. Let's appreciate him. Let's thank Dr. Sam because what we are seeing is from zero level to presenter.
Exactly, sir.
All right. Thank you very much. God bless you. Also, I want us to, because this, what we did today is a different dimension, it's a different level, it's a point that creates confidence to wisdom class that even the previous one we have learned they didn't have up to the confidence we are seeing. They craved for this, but it was not available to them. But I want us to appreciate Dr. Victoria because she's the one that initiated this and they bring this idea and they mention a lot of things that's going to impart in these people that are going. I want to appreciate, let's appreciate her. Let's appreciate Dr. Victoria at this moment because this idea you see is something that's going to transform a lot of wisdom class. Ability to present and defend place you on another platform than just being taught continuously. It's a very great initiative, and we are taking it on to the highest level. Thank you very much for all of you. I want to also definitely appreciate the leaders. As the leaders, some of them were sleepless nights to make sure this type of thing happen because they have surpassed our expectation, to be sincere. I didn't expect to this level because, but let's appreciate our leaders, all the leaders that definitely organize this. Let's appreciate them. Yes. Thank you very much. Thank you very much, all of you. Yeah. Thank you very much, all of you. God bless you for that because you're taking us to a different level. I'm telling you, the impact of what we have just done now will be felt even in individuals that are presented in their confidence, are built, great demonstrations. So finally, let's appreciate the presenters. Let's thank them for the confidence because there are some, this kind of thing needed for them to read extra. And we could see that they didn't just took what they read beyond what they were taught. And the way God helped them to deliver it is very, very wonderful. Very, very top notch in all this. But we thank God for the great thing He's started. We could see that the confidence are built even across the wisdom class. If you probably the next one is coming up, like Dr. Sam has mentioned, is going to be a bigger ones. Definitely, we are not the alumni will be. We didn't let them know, but they want to be in for the next one. The alumni will be in. This place is going to be jam packed. For the next one, we are going to make sure as a knowledge class, don't miss it because these are pointing to a lot of things. I'm telling you, at this level, those who read they are not in the same people that were taught before. And because these are really a wonderful thing. No one takes the glory, but God takes the glory. We just want to declare some prayer. Father, we thank you at this point in time for this building of life, for this we have seen, have really confirmed indeed we are not wasting our time. There are people that are being built. Yes, oh God, we thank you. We return all the glory to you. As we have seen this, Lord, let there be a greater manifestation in their lives, and even those that are in knowledge. Oh Father, I pray that you instead the inspiration for a greater height than just that, and that nature be glorified. Thank you, Father. In Jesus' name we pray. Amen.
Amen.
God bless you. I will invite Dr. Victoria to just make some comment, then we hand over to see what is happening. God bless you.
Okay, just very quickly, the Bible says we should give honor to whom honor is due. So let's just thank God for the initiator of CHM as a whole, Pastor Gibson. So let's celebrate the grace of God in his life. Father, we thank you. Thank you for Dr. Gibson. Let's appreciate him. And also, I just want to, again, just to echo what Pastor said, thank you to the leaders of Wisdom Class. They're just an amazing set. If you think that what happened today was great, that tells you what encouragement can do, what unity can do, what hard work can do, and what mentoring, obviously, from Dr. Sam so far in the class can do. So whenever you have to work with people, unity, encouragement, hard work, and when you have the mentor, this is the kind of thing. And this is the beginning, like I said at the start. God who has begun this good work, it will grow into a mighty tree in the future in Jesus' name. So sit tight. That will be all for me. Thank you very much.
Thank you so much, Dr. Victoria. Thank you so much, Pastor. Thank you, Dr. Sam. It's just so beautiful. Thank you, everybody, for being able to stay patient and just observe our hard work, what we've been doing, and what we've learned from Dr. Sam. But I know that everyone in behind the scene, they have a few things to say about our presentation. So I'm just going to take 1 or 2 minutes to quickly read what we have in the comment section so that we let you all know that we are paying attention to what you have to say to us as well. So Refa Henna said, wisdom class are just awesome. Thank you. Dayo Akinsola said, great presentation. Thank you. Mr. Moses Achiloko said, this is brilliant. Praise be to God. Is world-class work and presentation. Thank you, CHM. Thank you, Mr. Moses. I'm just going to take 2 more and we'll move on. Mr. Udo Ukeju said, I must say, Dr. Sam is a down-to-earth teacher I have ever seen. God bless you, Dr. Sam. Thank you, Mr. Udo, and I'm sure Dr. Sam can hear that. George Corey said, superb and excellent presentations by Wisdom class. I can imagine the work that went into creating this presentation. Kudos to the Wisdom class presenters and the CHM leaders, Dr. Sam, Dr. Gibson, and Dr. Victoria. Stay strengthened and remain blessed. Thank you so much. That's wonderful. Right, we can't take everything, but we just want to let you know that we are paying attention and we're listening. But before we finish completely, I would just like to call on my colleague, a fellow leader of the Wisdom class, to just come up. Mrs. Ozioma, can you just say 1 or 2 things to everyone? I'm sorry I'm putting you on the spot. I know you didn't expect this.
I didn't. I just want to say thank you to everyone. Thank you to the knowledge class for being guests. It was exciting because if we were not there, I mean, if we were presenting to ourselves, the excitement wouldn't be as it has been. Thank you to Dr. Sam. You've been an amazing teacher, like indefatigable, always willing to come in and help you. You've been an amazing mentor to all of us. Thank you to Dr. Victoria for the challenge. Honestly, when the challenge came, I was like, what do we have for this? But I mean, my colleagues are amazing. Everyone everyone rose to the challenge, and sleepless nights here and there, hard work, extra work here and there, but here we are. Thank you, Pastor Gibson, for the vision and for putting this whole thing together. And thank you, Joy, too. I know I have a little more time in my hands, but with all you have to do, you've been able to help gather everyone and help lead as we planned for this. So it's just a big thanks to everyone. And thank you for everyone that presented. All the hard work of organizing slides, reading, studying, researching. It's an amazing thing. I'm happy to be part of this particular class, actually. I've been encouraged, motivated, and inspired. Thank you, everyone. That's all from me.
Thank you, Mrs. Ozioma. That's wonderful. That's a fellow leader of the Wisdom class, and she's been great. I don't even have anything else I want to say because, to be honest with you, what we can all see here today is a result of dedication, is a result of patience, a result of unity, a result of hard work, sleepless nights. When you know what you want and you're going for it, nothing's stopping you, okay? I know that all of us are from different backgrounds. Some are doctors, some are nurses, some are, in fact, I don't even have an idea about computer, like all of this. But since I started in knowledge class, here I am today. I cannot thank Dr. Sam enough. I cannot thank Pastor Gibson enough. I cannot thank Dr. Victoria enough. And most importantly, all my colleagues, because you cannot do it alone. One tree can never, ever make a forest. So thank you, all my colleagues in Wisdom class. Thank you, everybody, for your patience. And that brings us to the end of today. And we thank God for all that has happened. Thank you very much. Bye.